The next subject I want to talk about are joints. Obviously, a big point of contention with a lot of our contractors. Josh, if you could kind of elaborate on the different types of joints and in your experiences from a mechanical process again or perspective, what can be done to prepare those joints?
The primary thing to look at first would be the joint type. There's going to be a control joint, construction joint, and expansion joint. This conversation, keep it simple. Let's just say expansion joints never should be filled. Should never try to fill something in that was designed to allow two different slabs to move. And that narrows us down to control joints and construction joints. A construction joint is a joint between two slabs that have been fused together. So based on one day's pour or one section's pour, they pour the slab, and then the second one is poured next to it, and then they're tied together. There's a procedure there, but that is a joint that's not really intended to move, though thermal expansion and contraction could cause it to move. It depends on the design. So that's a construction joint. That can be filled. A control joint can also be filled. That is a joint that's there to handle a certain amount of movement in the slab so the slab doesn't arbitrarily crack in different places. After the preparation, there's usually not going to be enough movement in that slab. That means it cannot be filled. If I prepare it correctly, and preparing correctly would be, depending on the type of the joint, its shape, I may have to saw cut it along the vertical walls to prepare it. There should not be any damage there as far as micro cracking like we would have in the instance of a crack, because that joint was placed there to naturally move. So that means the vertical walls of it that I can see from the top are probably not cracked because they were never fused at one time together. They just abut one another. I certainly can saw it if I want to open up that edge, or maybe because the repair material requires a sharp corner, or maybe the joint is a rounded edge. My primary focus is going to be to clean down inside it. Now I can pressure wash it, which using water before coating doesn't make a lot of sense, but it can be done, or shot blast it. If I shot blast it, that means the shot will actually go down inside there similar to a power washer, but dry and dustless. Clean out those vertical sides as well as the bottom of that joint. The whole idea is those vertical walls need to be clean enough, profiled to some extent, but mostly clean so that they become absorbent. As the chemical is applied to it, it will want to absorb into those vertical walls, almost going sideways and anchoring itself to each side. The concern would be if those joints are there because there's going to be movement in the slab, the last thing we want to think of is fusing two pieces of concrete together that somebody expects them to move. So most people would say that that would crack because the slab will move too much and it will crack that material. If the wrong material is used, certainly it can crack. Thermal expansion and contraction is a real thing. It does move, but it's a matter of reasonable expectation of movement. So when it expands and contracts, if the right material is used to fill it and it's bonded because of proper preparation, it can handle it almost like a shock absorber. It can handle the movement of those slabs. If the wrong material is used, certainly it could be so rigid that it would want to crack. Yeah, with preparation, it's pretty much back to the basics of getting it clean to make it contaminant free and absorbent. After that, it's up to the material that's used to say if it's going to be a successful joint repair or joint patching.
Paul, given that, what material would you recommend that would not crack?
Probably a better question to say, what are the different types and what are their purposes, the pros and cons of those? Traditionally, you have polyureas, epoxy, polyurethanes, and there are some derivatives of those that are the most likely type of products being used as a liquid applied joint filler of some sort. As Josh mentioned, expansion joints really should just be left to do exactly what they're supposed to do, or a specialty system for that. For control and construction joints, the pros and cons are this. You have the polyureas. The advantage of those is that they're very fast curing, and they're traditionally a little more pliable than the other two types, the epoxies and the polyurethanes. The downside is that anything that sets extremely quick, the faster that product cures, the less adhesion it can attain because it doesn't saturate what it's attaching to as well as something that has a longer time. So you have to think of concrete like a sponge. If you would take a sponge and dunk it in water and pull it back out, it's not going to get as wet as if you soak it in the water longer. So an epoxy and a polyurethane are going to attain greater adhesion in the same circumstance, same temperature, versus a polyurea. You can offset that by using a primer, but the whole concept of using a polyurea in the first place is speed. At best, they tend to break loose at one side or the other, or generically nicknamed zippering, where they'll kind of run down the one side, cut across, run down again, and go back and forth like a zipper. on both sides of the joint because they didn't soak into the joint wall far enough so that fine little skin, especially if it wasn't cut and cleaned, is either chalky or some sort of contaminant there. It bonded that, but it couldn't stay wet long enough to soak through it and actually bond into the concrete well enough. Epoxy joint materials are slower setting, so they're going to attain better adhesion than a polyurea would. The downside is contractors don't want to wait. They are not UV stable, where some polyurea joint materials can be, so they have a tendency to discolor, chalk, amber, whatever. They're more of a functional joint material versus they don't have the kind of aesthetic attributes that a polyurea would have. They do last a little bit longer because they soak longer, they get better adhesion. The downside is not UV stable, has a tendency to kind of chalk up. They discolor and stain, and they're slower. They are also less expensive. And then you get into the other type, and polyurethanes versus a polyurea are going to give you kind of similar elongation characteristics, although a polyurethane can go even further than polyurea joint materials can, and they can attain better adhesion than a polyurea would because they take longer to set up. Polyurethanes are going to be kind of gummy, almost like a chewing gum consistency, and have a tendency to chalk and stain. They're also not UV stable, depending on the isocyanate used, but it has outstanding adhesion. And it's going to have very good long-term performance, but it kind of stays somewhat sticky-ish. They stain really easily, and coatings especially don't like sticking to them. So they're better to be left exposed and honored through the surface. We have one called PolyJF. PolyJF is also a two-component polyurethane that does have MDI isocyanate in it, so it has outstanding adhesion even to metal. But the difference being is it's going to give you the semi-rigid characteristics of an epoxy joint material. It's going to set faster than an epoxy joint material, meaning you can shave it sooner and you can traffic it sooner as well as grind it sooner, but you still have the inherent issue discoloring. It's not UV stable. It could potentially chalk, but performance-wise, higher chemical resistance. It's not as susceptible to moisture like the other two would be. So moisture and alkalinity don't affect it as much. It has a much higher capacity for relative humidity and moisture vapor transmission than most traditional joint materials. Strength is higher than the concrete at about 14,000 PSI. So although think of it kind of like a polyurethane, Josh made a comment like a bumper, it's going to give you the ability to take an impact and rebound without causing a shock to the system above it. So it kind of absorbs that stress to some degree in the joint. So it alleviates the pressure on the wall and it alleviates the pressure on the system above it so that the cracks are unlikely to telegraph through. They get absorbed, that stress gets absorbed into it as almost like a cushion in the joint, causing the joint wall to not give way as easily and without creating a stress fracture in the coating system above it. So they all, again, have different attributes. It really just depends on what's the aesthetics that's wanted, what type of traffic is it going to have, and what kind of time do you have. There is no one-stop type product that will do everything that everybody wants in every specific thing. As far as all-around universal, I personally look at it without, favoring a product is what is going to perform the best to protect the joint, which is what a joint material is for, from breaking down and fracturing and collapsing down into the floor, and allow whatever type of traffic is going to be on there. You pick the system based off of the traffic and then work from that. If that means honoring the joint, you honor the joint. If you don't need to honor the joint and you want a seamless system, you have to understand the give and take of what are you doing, what's it going to look like. But one thing that most contractors fail to realize is when you're talking speed, especially with a joint, you're giving things up if you want something that's going to set up in a few minutes, because it can't, without priming, attain adhesion comparable to the other types of joint materials. They're just too fast.
I appreciate that. And, if we've learned nothing, I think it's important for every contractor to communicate with their supplier, basically match the product with the application and what the desires of the contractor may be. Paul, you've been a great source of information. We appreciate you taking the time to be with us. We will make sure if anybody needs to reach out, has additional questions, that your information is available to them. But once again, thank you very much, and we appreciate your time.
Thanks, Paul.
All right, I'm going to stop recording.